Awesome, it's recording. Okay, so today it's 10:17, and what we want to do today is we're going to talk about logarithms. Logarithms, right? Okay, so logarithms are exponents. They are. In fact, here it is again. If you have log of some base of an answer, you can transpose that into exponential form, okay? Which is the base to that exponent equals the answer, okay? So, example, if I have 10 to the x equals 100, we all know in this case that x is 2, right? Agree with that? We can transpose this into log base 10, right? So this number is the base, the 100 is the answer, and then it equals the exponent because logarithms are exponents. See how I transposed that pretty easily? I just took my base and did log of the base, that's a subscript number of the answer. And in your calculator, what do you know? If you tried this, if you tried our log of 100, I already know what the answer is. You know what the answer is. What's the answer going to, what's the calculator going to say? Log of 100 is going to be 2, right? Boom. It is 2 because the invisible 10 is saying 10 to what power is 100? The invisible base saying 10 to what power equals 100 is got to be 2, okay? Pretty easy. So,
why would you need this?
Oh my gosh. It's common. It's in, for instance, biology, chemistry, physics, anything with really, really big numbers, or really, really super small numbers like mole. Like you're talking about the mole concentration in chemistry. You guys, does that sound familiar, right?
Yeah.
Avogadro's number, which is a humongous number, right? Because you're talking about how many atoms are in like a substance, right? They'll use logarithms a lot. Anything that has exponents that you have to deal with, you use logarithms. Biology, you've got a petri dish full of cells, right? How many cells do you have? Trillions, right? Maybe, right? So you can transcribe that as in terms of an exponent, okay? So thank you, Sydney. Lots and lots of places. Now, will you guys ever use this? I hope so, because the people that use this math make money. Remember, right, Ben? If you want to follow the money, follow the math. It's true. It really is true, okay? All right, let's take a look at A. So we can do this. Base 10, right? Invisible base. So tell me, what's the answer to A? Transpose it into exponential form.
10 to the second equals 100.
Boom! 10 to the second equals 100. Thanks, Mac. Will everybody else catch up? Do you see what you did? Sky, B, what's it going to be? Three to the fourth power equals 81. That's it. Okay, boom. Emma, what's this one going to be?
5 to the negative 1 equals 22.
Exactly right. Now that doesn't seem quite right, but it really is, because that becomes 1/5, and we know 2/10 is also 1/5. So that's a true statement, isn't it? But all we want to do is just convert it, okay? Now rewrite in log form, okay? So now we're going to change it from exponential to log. So I'm going to go log. What's my base? What's my base? 10 of, what is that, 100,000? Of 100,000 equals 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect, okay? B, how are we going to write this? Log of, what's my base? 8 of
2
equals
1/3.
perfect. Awesome. It's that easy, okay? And we need to get good at this, transposing it from one to the other. It's actually not that hard. You guys see that? Okay, now, evaluate each log. Well, this is the same thing. I like to set them equal to x. If I set it equal to x, then I can evaluate. We can do these without a calculator. We really can. Because what's the invisible base here? Invisible base is 10. So we're going to go 10 to the x equals 1,000, right? Okay, Big brain, what is it?
3.
3. Easy, right? You could have gone, Mr. Davies, I'm not going to use my brain. And you could have said, I refuse to use my brain because I can use my calculator, right? You can use your calculator on this one. You could go log of 1,000, but we already know the answer is 3, right? Boom. 3. Cool. Okay, now 2, you can't use a calculator, but we can use our brain, okay? So let's transpose it into exponential form. So how am I going to rewrite this? 2 to the x equals 32. So you ready? 2 to what power equals 32? 5. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So x is 5. Okay, C, set it equal to x. Okay, let's transpose it. What are we going to write?
16 to the x.
Now this one's a little harder, but what do you think?
1/2.
1/2. 1/2. Because we know, well, at least we've learned that a 1/2 power is always a square root. You knew that, right? That a 1/2 power. So if I take, and I can show you why that works. I can make this 16 can be 4 squared. Watch how I do this mathematically. You okay with that? And I've got 4 to something equals 4 to something, so then I can have a 2x equals 1, or x is equal to 1/2. That's mathematically solved. That's kind of a cool way to do it, isn't it? Or you just know that if you took the square root of 16, that the square root of 16 is 4, but that's the same thing as 16 to the 1/2 power, right? Because square, thanks, Emma. What do you get? Thank you. All right. Hi, Zoe. Okay. Now, and Zoe notes are right here, okay? Now, how about D? Let's set it equal to x, right? Okay, Zoe, we'll do this really quickly. Watch. You watching, Zoe? Logarithms, right? You did this last year, I'm sure. We're going to go 5 to the x equals 1. Remember that, doing that last year? So it's just 5 to the x power equals 1, okay? 0, because anything to the 0 power is always 1, right? So x equals 0. Good job, Evan. Now, this one's kind of weird. 5 to the log base 5. Well, let's see. If I set this equal to x, right? I'm going to have 5 to the x equals log base 5 of 12, right? That's kind of weird, isn't it? But then this could be rewritten as 5 to the x, right? So this is 5 to the x equals a 5 to the x times 12. So it's just 12. ln of e to the 4, okay? So if I set it equal to x, these are the tricky ones, but we can do these, okay? There's an invisible base, right? What's my invisible base? E. So if I go e to the x, thanks. If I go e to the x equals e to the 4, then x has got to equal 4, right? Here you go, guys. Go. Okay. So x is equal to 4, okay? All right, now let's write a couple of rules down, okay? Let's write a couple of rules. I'm going to write a couple of rules on the base, on the side. Oops, sorry, am I going too fast? I do not want to go too fast. Let's get it 2 new rules, okay? Actually, let's go 3 new rules, okay? First of all, we know that log of any base of 1 is equal to log of any base of 1.
Is equal to 0.
Thank you, smart girl. How'd you know that? That was really brilliant.
Well, I learned this a lot last year.
Okay, we know that any number to the 0 power is equal to 1. That's what logs do, right? Any number to the 0 power is equal to 1. Nice. And you can try it on your calculator. What is log of? I try. Okay, we can go log of 1 is 0.
Can you hear?
Okay. Now let's learn another rule. Okay, if I have log of any base to that base to the x power, okay? That's got to be the same numbers. Just like f, same base, to the answer, that these, in a sense, cancel each other out, and you're just left with x, okay? Let's learn one more rule, the rule we did in question number E, okay? So if you have the base of a log of the base of x, that these cancel out and you're just left with x, okay? So those are 3 log rules that are handy to know, okay? I'll let you write those down and then we'll flip the page, okay? Sydney, they did a good job of teaching you logs last year.
I liked my mom. She was teacher last year.
Cool. You had a good teacher.
She was a college professor.
I like that. Okay, ready to turn the page? Sky, you got it? Turn the page. Okay, so on the back. Okay, so let's graph this. Okay, we're going to graph y equals 2 plus log. So before we do anything, what I want to do is graph the parent function. Let's first of all graph y equals log of x. Before I do anything, let's graph the parent function. Let's see what that's going to look like, okay? Well, one of the things I can do is get a t-table, right, and go to y equals, I'm going to go log of x, and if I graph it, I better change my window. That's a pretty bad window. I'm not seeing anything. Window's bad, so yeah, I see why the window's bad.
Does it start in the negative or the quadrant below?
You are ahead of everybody, so you want to just hold that question, please, because you just asked a really good question. Okay? Yes. Watch. Okay, if I graph it, it looks like this. Yeah, that's kind of a weird
Oh, it
graph.
starts.
That's kind of a weird graph. So let's go back to what Sydney was saying. Go ahead and get, this is my parent function. Okay. Okay, there you go. Before I do anything, let me ask you the easy question. So we know this. Can x be 0? It can't be 0, right? So at 0, we're going to put an asymptote, a vertical asymptote. Sydney, is it starting to look familiar? Okay. Okay. Let's go back to what else we also know. Log of 1. What's log of 1?
0.
You said it. What's log of 1? You said it earlier. What is it?
0.
0. So we know that it's got to go through 1, okay? Now, if we take a look at the graph, it is the inverse of e to the x. So it's the inverse. This one is the inverse of y equals 10 to the x, and 10 to the x looks like this, okay? And if this is its function and the log is its inverse, remember how we do the inverse? It's just the reflection. Because remember when we talked about inverses, it's just the reflection over this line right here. Kind of sloppy. Remember how we did that? The inverse is just reflection. So then the graph that we're looking for looks like that. Okay? So the graph we want to put down is this graph here. Okay, here's my parent function, okay? Here's my graph for my log. Let me erase the rest of this mess because I don't need it anymore. Oh, I should probably make a better eraser, but what are those erasers? Here they are. All right. So this is our log graph, okay? It's just the opposite of exponential. Exponential gets big fast, right? Exponential growth gets big fast, right? Exponentially growing. So logarithms does just the opposite. It will start to flatten out. Okay? An example of that is easy. You're gonna like this example. I've got a lake. Okay, and I feed it full of fish. I go in on the Forest Service and I dump it full of fish, right? Now the question is, if we leave it alone, let the habitat go for years, start with 100 fish, there is going to be a leveling off population. It has to be. It's a lake.
Yes.
You can only hold so many fish. If we never fish, we leave it alone, and then 10 years from now, Ben goes fishing, right? It's going to be full of fish. But there's a limit to the amount of fish, so it levels off. Does that make sense? Right? And that would be an example of a log graph. Pretty cool example, huh? And then Ben's going to go fishing, right? But this kind of graph would level off at, say, maybe it levels off to 10,000 trout. How's that sound, Ben?
Good.
Sounds good, right? Yeah. All right. So let's graph this one. So I want to graph this one. Here's my parent function. One of the ways we could do it is look at it on a calculator, but we probably don't need to look at it on a calculator. So I'm going to take this parent function, I'm going to move it up 2, right? So move it up 1, 2, so this point's going to be up here, okay? Okay.
It goes to the left.
Yeah, you're ahead of me. So 1, 2, so this point right here, where it goes through, it goes up to there, okay? So this point, my x-intercept now goes up to here, okay? And now if it's negative on the inside, it's going to spin it around the y-axis. So we're going to reflect over y-axis, right? So this graph is now going to go like this, right? So we're going to go and reflect it. So it's going to go kind of like that.
So the asymptote isn't there.
Asymptote is shifted. So it was here, and now it's got to be here. Okay, and the last 3 are going to take a calculator, okay? Right? The last 3 are going to take a calculator, which we can do. So solve for x. What's my invisible base? 10. Okay, so if we rewrite this as 10 to the 2.1 equals x, we can get the answer, right? What is 10 to the 2.1? 100 and something, right? Maybe bigger than 100. So if I go 10 to the 2.1, I get an answer about 125.9, approximately. How about b? What's my invisible base? E. So let's go e to the 2 power equals x, right? You guys with me? And what is e to the 2? I don't know. E to the 2. You are awesome. E to the 2 is about 7.3. We'll go 9. How's that? 7.389? 7.389 approximately equals x. Okay? And then number 3, or c, 2 to the negative 3 equals x. 2 to the negative 3 power equals x, or 1/8. Ooh, how did I get 1/8? Ooh, how did I get 1/8? Sky, you were talking about this earlier. Negative exponent, right? So it's 1 over 2 cubed, 2 times 2 times 2, or 1/8. How's that? Logarithms are pretty easy, okay? And man, we've got oodles of time to get the homework done. It's always a good thing, right? So I'm going to stop recording. I know I gave you a lot, but they're pretty easy, okay?